Hey guys, my name is Gavin, and today I'm going to be teaching you how to do antiderivatives. It's a pretty easy concept in calculus, just the opposite of derivatives. Derivatives, again, are pretty simple. So we'll start off with a little bit of derivative review. So 3x squared plus 2x plus 2. So how do we take the derivative? 3x squared plus 2x plus 2. How do you take the derivative of that? Well, with derivatives, you take the exponent, you bring it down in front, and you multiply it by the exponent. So it's either, if there's no coefficient right here, it would just be 2x. But since there's a 3, it's going to be 2 times 3, 6x. And then what do you need to do? Subtract 1 from the exponent. There's a 1 exponent, you don't need to. But yeah, 6x is the answer to that. Plus, take down the exponent from x to the 1 to x to the 0. X to the 0. What is x to the 0? X to the 0 is 1. What's 2 times 1? It's 2, obviously. So whenever you have a single coefficient, the answer is just going to be the coefficient. Last one. If you're taking away the x, what do we think the derivative of a constant is going to be? Derivative of a constant, said it a million times, derivative of a constant is 0. So plus 0. 3x squared plus 2x plus 2 is going to be 6x plus 2 plus 0, essentially, because that is how you do derivative. Let's do a couple more, just as a good base to review on, and then we'll get into the antiderivative stuff. So we can go, let's go 3 halves x to the 4th plus 2x squared minus 8x. How do we take the derivative of this? Again, bring the exponent down and multiply by the coefficient. So 3 halves times 4. How do you do that? It's actually not that bad. It's 1.5, so 1/2 of 4 is going to be 2. So it's going to be 6 halves, 6 halves. Sorry, I'm moving slow right now. That is not how you do it. 4 times 3 halves is going to be 6. Not 6 halves, just 6. So you got 6x. You got to still remember every single time, subtract 1 from the coefficient. So it's going to be 6x to the 3rd. And then you're at 2x squared. Again, 2 times 2 is 4. Minus 1 is 1. 4x. So plus 4x. Minus 8, because every single time it's just a single coefficient, no anything. Every single time it's just the coefficient number. Don't need to, you can literally just take away the x. Let's do one more. 3x squared plus 2x over 4x. How about, yeah, we'll do a little, don't worry about this, it's just like a little 3x squared plus 2x over 4x. How do you take a derivative of a fraction? Again, low D high minus high D low over low low. We should know this. I'm just trying to set the base for the antiderivatives. But yeah, derivative of a last one we will do. Low D high, low, 4x, times D high, derivative of the high. 2 times 3 is 6. 6x. Plus 2, because we're missing that 2. Low D high minus high D low. 3x squared plus 2x. X squared plus 2x times D low. The bottom is 4x. 4 times the derivative of the low times 4. Now, I know it's a little messy, but we can factor this out, or FOIL it out. So 4x plus 6x, or 4x times 6x, geez, is going to be, 18 to 6, 12, 18, 24. 24x squared plus 4 times 2 is 8x. 24x squared plus 8x minus, we still got to FOIL this, 4 times 3x squared is going to be 12x squared. And 2 times 4x, or 2x times 4 is 8x. So plus 8x. If you want to distribute the minus sign, these signs switch up, and it's going to be this over low 4x squared. We get the gist of it. So what is the difference between derivatives and antiderivatives? Antiderivatives is basically we're going to be doing the exact opposite of what I just did then. So let's just start off with the derivative of the first question, 6x plus 2. Six x plus 2. How do we take the antiderivative of 6x plus 2? Increase, divide, plus c. Increase, divide, plus c. How do you remember that? Increase, divide, plus c. That is literally the only thing you need to do. You increase the exponent of the coefficient, you divide by that new exponent, and then you add plus c at the end. So how do we get to that? Increase the exponent. It's going to end up x squared. Then we're going to, that's a bad 2. Sorry, it's just the marker's not too great. I can't write that clear. X squared. Divide. That's the increase part. Now we need to get to the divide part. There's still a 6 in front of here. What are we dividing by? We're dividing by the new exponent. The new exponent. So, over 2, 6 divided by 2 is what? 3x. For our first term, we have 3x squared. Next one, increase, divide, plus c. As you have imagined, that's it, 2x. That's all you need. It's increase, divide, plus c. What are you dividing by? The new coefficient. What is, or the new exponent, sorry, coefficient exponent. I'm mixing these up. The new exponent. What's the new exponent of 2x? It's 1. What's 2 divided by 1? It's 2. So, I've been saying plus c this whole time. What does plus c mean now? There's your answer. Let's take this back to the original and see what I did here. We started out with 3x squared plus 2x plus 2. 3x squared plus 2x plus c. So, it is not perfect. What's the difference here? You get plus c because the derivative of any constant is going to be 0, period. Every single constant, whether it's derivative of 1 is 0, derivative of 2 is 0, derivative of 5,736,852, it's 0. That's basically what it is. So when you do plus 0 at the end, you don't know if the constant was plus 1. You don't know if the constant was plus 5 million. So there's no way of actually knowing. That's just another part of the uncertainty of math, because there's so much uncertainty. But yeah, so you just do a little variable. Jeez, I'm not thinking my words right now. You add a little variable c in place of the constant that was here, because you don't know what it is, and to be fair, it doesn't really matter that much. It's all right. Next question. Let's get a little bit more complicated. What is the antiderivative of square root of x? How do you do that? That's complicated. How do I even take the derivative of this? You should know how to do that. You should know how to take derivative before you even think about antiderivatives, but I'll show you how no matter what. First step is always to rewrite an equation. You always want it in terms of just numbers, letters with exponents. Like, you don't need any of these extra signs, this square root sign. Who cares about the square root sign? Square root sign's boring. I don't want to listen to the square root sign. I want to see exponents. X to the 1/2 is the exact same thing as square root x. Now we got that out of the way, increase, divide, plus c. That's what you need to do. Increase, divide, plus c. Again, what does that mean? Increase by 1. X to the 3/2. Now we need to divide. You need to divide. Oh, wait. What do you divide by? 3/2? You can't divide by. This looks weird, right? X to the 3/2 divided by 3/2. You can't do that. Boo. Yeah, there's a way to fix that. Don't worry. X to the 3/2. Dividing by 3/2 is the exact same thing as multiplying by 2/3. You take the reciprocal of the exponent and you put that in front as a multiplication factor. So, this thing circled right here. Here's your answer. 2/3 x to the 3/2. That is square root of x antiderivative. Yeah, it's pretty easy. Like, we all understand dividing, yeah. I explained this a bunch of times. Dividing by 3/2 is the same thing as multiplying by 2/3. Oh, what if the coefficient is 7/3? Dividing by 7/3 is the same thing as multiplying by 3/7. So you don't have to divide by a whole nother division equation. You can just multiply it by the reciprocal. That makes that much easier. Next up, we got 3x minus. Let's think of a fun one. Let's think of a really fun one. One over x. Now, I just made these numbers up in my head, so I'm going to be doing this for the first time as well. So take pity on me, because this was both of our first time seeing this problem. Okay, 1 over x, increase. Oh, wait, what is 1 over x? Rewrite the equation. Rewrite it. Like I did with the square root x, you can rewrite this as well. What is that? X to the -1. Okay, wait. It is x to the -1, and when you increase, you get 0, and then scrap that one. Scrap that one. I'm going to say it's just for the plot. We're going to do same equation. That stuff gets a little more complicated. I just made it up. Sorry, bad number. X to the -2. Let's do that. X to the -2. Increase by 1. How do you do that? Come on, what is this, 3rd grade? Yeah. Increase by 1, x to the -1. Divide by the new one. Dividing by -1. What does that get you? Dividing by -1 is, we'll just put it as a placeholder for now. So we got x to the -1 over -1. We got 6x squared plus 4x minus 6x squared. Geez, sorry. So minus 6x squared, increase, divide, plus c. 3, the exponent becomes 3. Divided by 3. What's 6 divided by 3? It's 2. 2x to the 3rd plus 4. We all know how to do this. We've done this a bunch of times. How do we figure this one out, though? Minus, wait, what? Like what? Never fear. It's not that bad. Literally, x to the -1 is the exact same thing as 1 over x. But when there's a negative 1 in the denominator, it's going to be what? Negative 1 over x. Does that make sense? Because x to the negative 1 equals 1 over x. We'll just rewrite the equation right here. 1 over x. This negative sign just gets transferred to right here. Minus 2x to the third plus 4. That's the answer to the last equation. And yeah, thank you very much. That was the intro to how to do antiderivatives. It's really not that hard of a thing to do. Increase, divide, plus c. That's all it is. There's no other rule, no special rules, nothing else. It'll get a little bit more complicated as you get into it with all these like intricate equations, but that's the basics. You just got to start with the basics and then practice those, get better. Yeah, and then maybe next year I'll make an even more complicated video. But for now, that is my math final. I am done with all my work from senior year, from high school. I'm done with high school. Thank you.